The rail pressure sensor is designed to convert fuel rail pressure values into voltage signals for the engine control unit. The ECM supplies a 5-volt reference and low reference to the sensor. Varying signal voltages are returned to the ECM based on fuel pressure within the rail. When the fuel pressure is high, the signal voltage is high. When the fuel pressure is low, so the signal voltage is also low. The diagnostics for these codes will run only when the engine is running and the battery level is greater than 11 volts. A P0192 will be recorded if the sensor signal voltage is lower than a predetermined value. This may be caused by an open or short to ground in the high reference circuit, or by an open, excess resistance, or short to ground in a pull-down type signal circuit. Having a battery maintainer connected during any electrical checks will guarantee stable voltage readings. Disconnect the harness connector at the fuel rail pressure sensor and attach a meter set on volts between battery negative and the high reference terminal. Turn the ignition on and record the voltage. The expected value would be between 4.8 and 5.2 volts. To confirm or rule out a short to ground, move the meter lead to battery positive and watch the display. Any meter reading seen now will confirm a short to ground. Turn the ignition off and disconnect the ECM. Turn the ignition on and watch the display. If the meter now reads 0, there is a short to ground in the ECM or another circuit from the ECM. To isolate, perform a continuity test between the high reference terminal at the fuel rail pressure sensor harness connector and all other ECM terminals. If continuity is not found in any circuit, the fault will be a short to ground in the ECM. If the meter displayed any continuity, the short is in that circuit. If, when the ECM was initially disconnected, the meter display was still high, the short to ground is in the harness between the two connectors. If the initial recorded voltage reading from the high reference circuit indicated a 0 voltage, connect the meter at battery negative with one lead and back probe the high reference terminal at the ECM connector with the other. If the meter now displays between 4.8 and 5.2 volts, the open is in the harness between the two connectors. If the meter reading is still lower than expected, turn the ignition off and disconnect the ECM. Inspect the high reference terminal in the harness connector and ECM for corrosion and terminal tension. If no fault can be found, the open is internal to the ECM. With the ignition off, disconnect the fuel rail pressure sensor harness connector. Set the meter on volts and connect between battery positive and the signal terminal in the harness connector. You should see battery voltage displayed. This may also indicate a short to ground. No reading indicates an open, while a significantly lower value points to a circuit resistance fault. Move 1 meter lead to the ECM connector and back probe the signal terminal while watching the display. If the correct voltage is now shown, the open or excess resistance is between the two connectors. If the meter still displays a lower than expected value, disconnect the ECM and inspect the signal terminal in the harness connector and ECM for corrosion and terminal tension. If no fault can be found, the open or excess resistance is internal to the ECM. This test should be performed after an open has been ruled out. Using a scan tool, navigate to the fuel rail pressure sensor data. Remove the harness connector and place a 3 amp fuse jumper between the high reference terminal and the signal terminal. The scan tool data should display between 4.8 and 5.2 volts. If the value remains on 0, a short to ground can be confirmed. Turn the ignition off and disconnect the ECM. Perform a continuity test between the fuel rail pressure sensor harness connector signal terminal and battery negative. Any value displayed indicates a short to ground in the harness. If there is no meter reading, the short to ground is in the ECM. If the high reference and signal circuit test OK, the DTC can only have been caused by the sensor. Continuous training will guarantee effective diagnosis will be reached in minimal time. Thanks for watching.